Alright, I'm Professor Ramirez, and I'm going to teach Madib and Anish how to find domain, range, vertical asymptote, horizontal asymptote, oblique asymptote, and holes.
Mr. Ramirez, is this going to be a hard thing to do?
Bro, pay attention in class. So, Mr. Ramirez, so how do we find the domain?
Alright, Madib, can you smack him harder next time? Anyways, this is how we do it. So, first, you're going to set the denominator to equal 0. Then you're going to solve for x. Then exclude these values from the domain. But if it's factorable, like in this equation, you're going to want to factor it. Let me show you how to do that. Okay, so this is a factored form. Wait, that's a hole. X minus 2, when it's on the top and the bottom, it's a hole. And we get to cancel it out.
What's a hole?
Bro, Anish, be quiet. We'll get to that later. First, let's find how to do the domain.
Okay, fine.
Anyways, even though we still have holes, we're still gonna have to set both of the bottom ones equal to 0, including the one that crossed out. Alright, well, let me show you how to do it. So you would have to make x plus 2 equal to 0, and then x minus 2 equal to 0, because they're both right here. And this would be x equals negative 2, and x equals positive 2. And then, once you have those, you want to put it on the graph. So, negative 2 would be one of them, and positive 2 would be one of them.
Okay, I get it. So how to list it? Anish, what are you doing?
Bro, Anish, start paying attention. Anyways, Madib, this is how you write it. So you'd say domain equals negative infinity to negative 2, right? Because you'd stop at negative 2. Put it into parentheses. U, negative 2 to 2, put into parentheses. And then we're going to make some space here. And we're going to do U2 to infinity. You get it, Madib?
Oh, I get it. So what do I do with the holes?
Madib, you probably want to look behind you. Anyways, that's a good question. Let me just clear this up so I can make space to show you. Alright, so now that it's cleared out, I'll show y'all how to do it. So the hole is x minus 2, right? Equals 0. So you'd have to just solve for x, which is x plus 2, and then, or x equals 2, and then you'd have to plug it in here. So 2 plus 4 over 2 plus 2 equals 6 over 4. And then you could simplify that into 3 over 2, and that would be the y of the hole. So it'd be about 2, 3 over 2, so like right around here. Oh, and also remember to not plug in 2 into the cancel values, just to plug it into these to find your y value.
Okay, so what about the vertical asymptote?
Bro!
Anish, how are you even gaming in class? Anyways, Madib, good question. So to find the vertical asymptote, we'd have to set the denominator. It'd just be what the denominator is equal to 0, which is x equals negative 2. And it wouldn't be this because we already canceled it out because it's a hole, which means that that is not a vertical asymptote. It's just a hole. So the vertical asymptote is just x equals negative 2.
So Mr. Ramirez, how do we find the horizontal asymptote?
Alright, Mandy, let me write the rules real quick. Okay, so in horizontal asymptote, if the numerator degree is smaller than the denominator degree, then y would equal 0. Like right here, the degree is 1, and right here it's 2. So it just equals 0. And if the numerator degree is larger than the denominator degree, then it's just none. And if they're both equal, such as right here, they're both 1, then it's just the leading coefficient. But for our example, as you can see, our degree, leading degree, for both is 2. So it's equal. So we'd have to do the leading coefficient, which is just 1. So we put it at 1.
Wouldn't that try to do the range?
Alright, so to find the range, we'd have to use these rules, and we'd do the graph, and the asymptote is y equals 1, so it's like that. And then it'd be negative infinity to 1, and then u 1 to positive infinity.
How do you do the oblique asymptote?
Mindy, I don't really know how to do it.
You know what? I do.
Wait, what?
Get the hell out of here. When the degree of the numerator is greater by exactly 1 by the denominator, you divide the numerator by denominator. Let me show you something. With that, our quotient would be x minus 1, and we forget the remainder. And with that, we put that and make it y equals x minus 1, and put it here.